added them all up and divided, yeah? Please tell me no.
Calculator did.
Yes, thank you. We are done with that stuff. We are done. We are done with calculating these things manually. It takes far too long, especially when you get larger data sets. Especially when you get larger data sets. So for the weight loss data, let's all make sure we can do this. You ran one of our stats, right, Shaylee?
Yes.
So stat, you're in your stat, you go to calc. There we go. Calc, one of our stats, first choice. And I put mine in L1. Did you put yours in L1? I'm assuming you did too. Just press enter. Boom. 35 data points. We got a bunch of stuff here, which is fantastic. Yay. The very first one, X bar. X bar is about negative 14.7 pounds. Interpret that for me again. What does it mean to have an average of negative 14.7 pounds? What does that mean?
On average over time,
Good.
those women lost 14
So these 35 women, not all of them lost weight, right? But on average, they lost 14.7 pounds. Meaning, what happened to the ones that gained 58? What happened to them? What happens to the average? What happens to those folks? Look back at your data. Look back at your data, yes? See that person in there that lost 58?
Yes.
That person took 45, if I'm doing the math right in my head, I'm probably not. That's about negative 15, yes? That person took 43 of her extra pounds that she lost and distributed those negative 43 pounds to other people who gained weight, which knocked them down. And the people that were below average distributed out their negatives to those that were above and knocked them down. And once you distributed, there's the sum total of all the weight losses. There was a combined total of negative 515 pounds lost. There's actually more than that lost because that's what the positives added into it. There was actually more negative than positive. That's how much more negative there was than positive, negative 515 pounds. That split evenly over 35 women results in negative 14.7. So it's that balance point. If you were to put your hand on a tray, it's where your hand would have to be to balance it. We're about to see that tray. I see no tray. He's speaking of this tray and these cookies. I see no tray, I see no cookies. It would be helpful to get a tray and cookies, but we'll get back to that. We'll get back to that momentarily. I do want to do that in our TIs. Good, good. What else am I extraordinarily... Oh, actually, before I ask this question. So the diet is a success. We lose on average 14.7 pounds, yes? Well, on average, yes. But what does that ignore?
Weight gain.
Well, it ignores weight gained. Well, it kind of does. It kind of doesn't, though. It's like saying, on average, stick your head in the fridge and your feet in the freezer, you're average, you're fine. So what does it ignore? It ignores the variation around the data, yes? Because on average, they lost 14.7 pounds. How many gained weight? We've now lost that beautiful 20% that we had before versus the 80%. It would be nice to bring all that together in one kind of collective. This is the guy I want to talk about too, that's 16.4. This is about 16.4 pounds as well. So the question now is that big or is it small? This goes back to Aaron's point. Is that big or is that small? I don't want to answer that question right now. I don't want to answer that question right now. Instead of answering that question, I want to talk about the plate of cookies, the balance point that the average is, and how the standard deviation acts around that plate of cookies. So here's the next thing I want to do. I want to take a look at this data in histogram form. So I want to draw a histogram. Now we can do that by hand. I don't recommend doing that. It's a pain in the butt. It's way easier to use technology to draw a histogram and utilize technology. So we're going to learn how to do it on our TIs right now. You already have the data in, yes? Now we're going to, no? We'll go ahead and do it.